If y is equal to h of x is graphed in the xy plane, which the following represents the real-life meaning of the positive x-intercept? The x-intercept is when y is equal to 0. So this is when it's been launched, but that's the time when it hits the ground. So we have launched, impact with ground. According to the model, at what speed in miles per hour does the car obtain its greatest gas mileage? We're going to use the formula for the vertex, negative b over 2a, so I'm going to take negative 4 divided by negative 1/12. Another way of saying that, instead of dividing by a negative 1/12, is to multiply by a negative 12 over 1. This gives me 48. That's the x-coordinate of the vertex, which would be the maximum. Here's my equation, 3x squared plus 6x plus 2. What feature of the graph is displayed as a constant or coefficient? So if you plug in a 0 for x, you will get y equals 2, which is your y-intercept. That's shown there as a constant. Translating this into vertex form, I have to figure out what this value in front of the parentheses is going to be. I can do that by plugging in 0. 0 minus 4 squared is going to be 16. 16 plus 19. So I'm going to multiply 16 by a negative 1. And if I do so, then I add 19, I get 3. So this is my equation for the parabola. Now I need to find the equation for the line. If I look at the change in y over the change in x, I have 8 over 2, or in other words 4. And I have my intercept here is 9. So y is equal to 4x minus 9. And now I have two equations that I can set equal to each other to find out when they cross. That'll be the solution. So I'll start here. I'll subtract 19. I'll divide everything by negative 1. So I have negative 4x plus 28 is equal to x minus 4 squared. This is going to expand to x squared minus 8x plus 16. I'll move everything back over, so I have 0 is equal to x squared minus 4x minus 12. So I'm looking for factors of 12 that add up to 4, 6 and 2, x minus 6 and x plus 2. So my two factors are 6 and negative 2. The one that shows up here, v is going to be equal to 6. My intercepts here are negative 6 and positive 4. There's a distance of 10 between them, so if I go 5 over, x equals negative 1. That's going to be the x-coordinate of my vertex. So then if I plug that in, and I have negative 1 plus 6, which is 5, times negative 1 minus 4, which is negative 5, I get negative 25. So y is equal to negative 25. That's my vertex. So to write this in vertex form, I'm going to say x minus a negative 1, which is plus 1, squared, minus 25. So this appears to be a parabola that opens down, so I'm looking for a negative a value. That rules out a and c. So let's pick one of these and find the vertex. Negative 19.76 all over 2 times negative 1.67. This is going to come out positive, which is what I want for my x-coordinate. If I tried it with this one, this would be 19.76 divided by 2 times negative 1.67, which comes out negative. And notice my vertex would not be negative, so I'm going to pick D. So they want to take this equation and put it in vertex form. So the vertex here is 1, negative 16. So we can write that as x minus 1 squared minus 16, which is D. An arrow is launched upward with initial speed of 100 meters per second. They tell us that v0 is the initial speed, which is 100 meters per second. V is the speed of the arrow as it is moving up in the air, so that changes over time. H is the height of the arrow above the ground. and t is the time elapsed since the arrow was projected upward, and g is the acceleration due to gravity, which they tell is 9.8 meters per second squared. So this is my height equation, and for v sub 0 I can plug in 100, and for g I can plug in 9.8, and this is what I get. If I'm looking for a maximum height, well, first of all, it's going to be a parabola like this, so I'm looking for the vertex. If I want to find the vertex, I need to take negative b over 2a. So the a value is always going to be in front of the x squared term, or in this case the t squared term, so it's negative 4.9. And the b value is in front of the x, or the t, so that's 100. So negative 100 divided by 2 times negative 4.9. This tells me the x-coordinate of the vertex, which is about 10.2. If I take that coordinate and plug it back in for t in this equation, I get an answer of 510 after I simplify everything. And that is the maximum height, the y-coordinate of the vertex. How long will it take for the arrow to reach its maximum height? So that goes back to the previous problem, and it's this answer 10.2, which was the x-coordinate, or the amount of time. In this first graph, my vertex is going to be here at 6, 3. In this second graph, my vertex is going to be at negative 5, 3. So how did I go from red to blue? I moved 11 units to the right. 5 to get to 0, and then 6 more.